All right, this is our next topic. We are going to learn how to add and subtract vectors. Just like scalars, vectors can be added or subtracted. However, unlike scalars, vectors have to be added in a way that takes into consideration their direction and magnitude. We can't just add them using mathematics. So normally we add numbers 10 plus 5, 15, however, in a vector addition problem, we have to take into consideration the direction. So there are two different ways to add vectors or and subtract vectors. First, we're going to learn how to do them graphically, and then we're going to learn how to add and subtract them using their components. So when adding them graphically, we will use what I call a tip to tail approach. The tip represents the start of the vector while the tail represents the end of the vector. So for example, vectors are drawn by an arrow. The arrow points the direction. The arrow is the end. That is the tail of the vector, and this is considered the tip. Now the book calls it tail and the head of the vector. I don't know. I like tip to tail better. That's a trick, a phrase that seems like it would be easier to remember. So to add two vectors, A and B, place the tail end of B to the head of A. Okay, so we'll just replace that with the tip. I like tip better, tip to tail. So let's read that again. To add two vectors, so I have a vector A and a vector B, place the tail of B at the tip of A. Okay, so what do I do? If I have a vector A and I have a vector B, I will draw vector A. There's the tip, there's the tail. And I want to take vector B and draw it, let's say it's straight to the right. So this is B. And this is the tip, and this is the tail. You'll notice that we have in this area tip to tail. Okay, so that's how I add the two. I draw them, and then I will start at the origin, which does not have the arrow, and draw a line straight to the final location. And this is the result of A plus B. This is my resultant vector. We'll call it C, okay? So I have just added vector A plus B to get C. Okay, so notice to this picture, I'm just going to redraw as I write. This student walks 5 paces north, okay? And we'll call that vector A. And then walks 3 paces east. Notice the line is not quite as long because the length represents the magnitude. And we can then, that is actually drawn tip to tail. I can draw a line going from the origin to the final location, and that will represent the addition of A plus B. So A vector plus C vector is equal to, I'm sorry, A vector plus that B vector is equal to the C vector that I just drew. And we could use a protractor and a ruler and a scale to actually determine that magnitude of that C. We can actually even measure the angle. Adding vectors graphically is not fun, and it's a very difficult task. Visually we can see it, but actually measuring the amount or the length is not an easy thing to do. I could add more than one vector. Take a look at this one. This person walked this picture right here. I'm just redrawing it. So 5 paces north, 3 paces east, then 4 paces southeast. So he went 5, then 3, and then I draw the next vector, which was 4 at southeast. And again, I will start from the origin and draw an arrow to the location, and that we'll call that vector D. So this is A, this is the vector A, which equals 5. This was the vector B, which equals 3. And this was the vector C, which equaled 4. Okay, so I can actually add more than one vector. Okay, but here's the key to adding them graphically. Tip to tail, and then start at origin and draw an arrow to final location as shown right here. And that is the result of adding all those vectors. So the vector D was equal to the vector A plus that vector B plus that vector C. The little arrow on top represents a vector symbol. Often Mrs. Query leaves it off because I'm kind of sloppy that way, but for the purposes of teaching you about vectors, I'll leave the little arrow hat on there. Okay, vectors are equivalent if they're equal in magnitude and direction only. They are not changed. They are unchanged if you pick them up and move them to a location, as long as you have the same magnitude and the same direction. So notice all of these vectors A here. They all have the same exact length of the line, and they are all parallel to one another. So they actually have the same direction. Every single one of these vectors are equal to each other, okay? Because it doesn't matter. The origin of it doesn't matter. So I can pick that line up, and that is why we're able to do this. Because of this fact, it doesn't matter which order you draw them. So for example, I have drawn A first, and then I drew tip to tail B, and then I found my resultant vector C. I started at the origin and went to the end. And notice if I then came along and did B first, then A, I will still get C, and it's identical in length and in the direction that it's pointing. So if you then were to go and calculate this angle, it will have been the same as it was over here. So it doesn't matter which order that you have add the vectors together, okay? Now, I want to talk about how do I subtract vectors. The book didn't do a very good job. So we know how to do vector A plus B is equal to C, okay? So let's come up with a vector. Let's make, let's pretend that I have A, this is vector A, and let's have vector B go this way. And let's say this is C, which is the addition of the two of them, okay? And the only problem I have is that I can't see A very well. So let's put A over here, and I'll put C this way. All right, there's A plus B. What happens when I have A minus B? How do I do that? So how we do that is we use a little bit of math term. Isn't this the same if I add the negative of B? So instead of subtracting, I'm just going to add the negative of B. Well, what's the negative of B? Well, I come along and I just draw B in the opposite direction. This is the negative of B, okay? And so in that situation, I start at the origin and I go here to the final location. And so D represents A vector minus B vector, okay? So how I subtract is I add the reverse direction, okay? It's a little bit more, the book doesn't do a good job of showing you how to do that graphically, but I wanted to show you that. The easiest way to add and subtract vectors is to add them by their components, and that is the next lesson. So we'll do that in a different class period, but basically this is your introduction to adding and subtracting vectors graphically. That's what I got. Hope you have a good day.